Welcome back to another stream. We have a special guest today, Sherry Conrad. We're going to talk about Cisco Catalyst SD-WAN, what used to be Cisco SD-WAN, what used to be Viptela. So there's been a lot of rebranding and renaming, but super excited to have Sherry with us. We're going to talk all about hybrid architectures, public cloud deployments, expanding your SD-WAN fabrics into AWS and Azure, and any questions that come up, any other topics around infrastructure automation, they're all up for discussion. Sherry, I'll pass the mic to you. Let you introduce yourself. Tell us a couple of words about yourself, what you do, what's your role at Cisco, and yeah, super excited to have you.
Absolutely. Nice to meet you. So, my name is Sherry Conrad. I'm on the Global Partner Engineering team. And what I really specialize in is working with our partners, mostly our largest partners at Cisco. So, a lot of the multiple service providers, MSPs, telcos, and so forth, um, to assist their teams in automation endeavors, specifically with a focus on APIs. So, today, what I would like to show you in the context of Viptela SD-WAN is some more of a DevOps way of automating SD-WAN. Now, we all know at Cisco, we have a wide range of options for automation. But the trend that I'm seeing more and more with our very large partners is they are starting to hire very highly skilled developers into their network teams. Or they have DevOps teams that are working very closely with the traditional LAN-based networking teams. And this is enabling them to write, deploy as much of the infrastructure as code as possible. Now, today what I'm going to show you is a test environment. So even if you have your Viptela SD-WAN hosted with Cisco, you're always going to want to have a test environment, especially if you're a partner who is developing software to the Viptela SD-WAN APIs. You may be building your own AI ops solution and integrating it with all your other software and tools in your organization. And so if you don't have your automation really buttoned down, or if you're using a variety of tools, what I'm going to show you today is perhaps a different way of working. It's not using Ansible, it's not using Terraform. It's essentially using a CI/CD pipeline, and that pipeline is logging into all the resources, so all the cloud providers, the Git resource to pull the code, and as well, it's doing some basic linting. And now, typically speaking, we would have some other things plugged into the pipeline, such as code scanners for security purpose, make sure nothing gets pushed up into the Git repo that shouldn't be, like an SSH key or so forth, as well as something like SonarQube. So this is a very simple architecture. So what I'm going to do now is I'm going to share my screen. I'm going to give you a very high level component block architecture, and then I'm going to jump right in, and we're going to see an SD-WAN deployment, MSP deployment. So it's a cluster. There's going to be a tenant deployed. I'm going to show you how to set up the licensing for an MSP. And I'm going to talk about why you would want to use MSP mode in Viptela, even if you're not a telco or service provider. So we'll get into that. And so let's go ahead and get started. So nice to meet you.
All right.
Share my screen. All right.
Cool.
So I believe it might be the wrong screen. So if I think I got 3 screens. So yeah, this is the one.
Let's see.
All right, here we go.
All right, there we go.
All right. Okay, I did have, this is a quick slide of me, my title, Programmability Lead, my team. I'm on GPRS Solutions. There's my dogs. You may hear my dogs bark during this meeting. My family, my son, my husband, and, we're just typical family, likes the outdoors, likes eating our food, and yeah, healthy living. Here's a little bit of what I do, just to recap. So, partner enablement, proof of concept, labs, which is code as infrastructure as code, which will go into your environment, and labs and training, Cisco Live, and some strategy in regards to our APIs. So let's dive right in now. And I did promise a quick diagram. This is the last PowerPoint. This is our component block architecture for the demo today. So this is a very standard DevOps, NetOps component block architecture, and it uses the rapid iteration software development lifecycle, where as developers, we write some code towards our release or a bug fix. We test it out, we test it in our pipeline. If it passes, it goes through our different environments, so dev, test, QA, prod, um, and then it can even roll right through into production. So in this case, we're just going to look at one environment today. That's all we have time for. But essentially, our component block architecture is from the developer's brain, which is this first icon here, into our code repo. So we're using Git. And again, don't think that you're married to these tools. These are placeholders. So some people don't use Git. They have their own internal tools that are different. And then from Git, what it does is it actually goes to the CI/CD pipeline, and the CI/CD pipeline is authenticated into the cloud, into a HashiCorp vault, which is this lock sign here. We're using the HashiCorp as an artifactory. So you could have JFrog here, you could have Azure Vault, you could have AWS Vault, but in this case, you're going to use HashiCorp. So what this means is that all of our variable values, everything that is going to be created from the pipeline, ingested by the pipeline, it's going to go into the vault, and it's going to go in a multi-tenancy fashion. And I'm going to show you that in the code walkthrough in a minute. But each tenant is going to have its own mount point in the vault with all the artifacts from the deployment. And this is really important because from time to time, you will have a situation. I had a situation this morning when I fired up my environment, and some Elastic IPs had just become disassociated with my vBond instances. And so I was able to very rapidly go into my vault for that particular tenant, find the Elastic IPs for the specific interfaces for the instance, reattach them, and I was back up and running. And so when we're doing this automation, we always want to store all our artifacts somewhere. And then essentially what's happening is Concourse is calling our image from Docker that has all our libs, our Python version, our AWS CLI version, everything on there that we need to build our code. And it is pulling it, creating an ephemeral build container. And then what it's doing is building our code, and it is pushing our underlay into the cloud. And once our underlay is up, it is going to deploy our instances, and then it is going to configure our instances. Now, I have a few other things in this diagram you can disregard for this demo: Thousand Eyes and Intersight, NAPD, and Kubernetes. So I'm going to just minimize the slide. And one more slide. Let's look at one more slide. Okay. I just want to refresh everybody on the SD-WAN high-level architecture. So as you know, the beauty of SD-WAN is we've separated the control plane from the data plane. And on the control plane, we have, the vSmart controllers, which push down all of our routing configuration to our edge devices, like our vEdge, our Cat 8Ks, our CSR 1000Bs, etc. And then we have the data plane, which is where our zero-touch provisioning and our physical or our virtual exists. Okay, so that's very simple. There's a lot more to it, but what we're going to do right now is jump right in. And this morning, I used the CI/CD pipeline. So my brain into Git. Here's the Git repo that has all the code. So this entire environment is
Sherry,
yes.
can you increase the text size, please, a bit?
In which? In the IDE or?
Both.
Yeah, absolutely. One moment. Let me go to
Thanks.
settings, and I'm going to go to font, and let's try 20. Let's see if that's enough. Is that better? More?
It is, yes.
You know what?
Can we
Maybe
do
I'll,
like maybe 22? Yeah.
yeah. How's that?
Yes, much better.
Okay, and I can make this bigger too. All right, so as in our diagram, right, as a developer, we use our brain, we write the code, it goes into our repo. So this is my repo here. And you can see I'm on a branch, release 1.0 US West 2A. That's my release that I'm on. And all the code is in here. So what happens is when I do a commit and I push, it updates the branch. And when I do that commit, it kicks off my pipeline. So this is my concourse pipeline. And as you can see, this is building from this commit. So it shows me my commit, my date, and it shows me the URL to that commit in the Git branch. And here's the branch. So I know that my pipeline is building that branch. Okay. So what it does is once that Git commit happens, it kicks off a pipeline build and it deploys the underlay. So each one of these boxes here is a job. And the first job that runs, well, there's two jobs that run in parallel: a deploy Elastic IPs and deploy AWS VPC. Now these are all green. I ran these in advance because although it takes a few minutes for the underlay to spin up and for the instances to deploy, and for the instances to have the initial configuration, they actually have to reboot 3 times, and it can take sometimes over an hour. So we don't have that much time. So I did this in advance. But if we go ahead and we look at our pipeline, we can see that we have all the standard out, the time date, the timestamps, everything that was done in AWS. And at the end of it, we can see our pipeline. If I scroll way down to the end, it wrote all my artifacts into my vault. Now, let's see what it did, okay? It built the entire MSP cluster based off of 3 variables only. And so why is this important? Well, if you were automating building clusters, SD-WAN clusters for your customers, then you would want to do this in an automated fashion, right? And you would want to have all of the artifacts available in the vault in the event that you needed to roll something back, upgrade something, restore something. And so if we go here and we look at tasks, the first thing that our pipeline did was it deployed the underlay. So we'll just look at that very quickly, and the EIPs. So it ran all these jobs to provision in advance our cluster IPs. So on each of our vManage 1, 2, and 3, we have an index 0, 1, and 2 NIC. Now, of course, it's very important in the cloud provider that you have the right NIC on the right VPN. And so you need to keep meticulous track of the indexes that these Elastic IPs are assigned to. So we provision them in advance, write them in the vault, and then when we spin up the instances, we call those values out of the vault and we assign them to the network cards so that everything comes up correctly on the right subnets and so forth. So we provision the EIPs, and then we go ahead and we provision the actual environment. So this is going ahead, and it's actually creating the VPC, writes VPC ID to the vault, creates the management subnet, and every time you create any object in the cloud, it has a unique identifier. Those unique identifiers are all written to the vault. So in this architecture, we're creating VPC management subnet and a cluster subnet, and then VPN 0 subnet. Creates the internet gateway, attaches it to the correct VPC, tags everything, creates the route tables, creates the firewall tables. What else does it do? It does everything for the underlay. Once this job is completed, and it provided it's successful, which it is, it automatically kicks off and deploys the instances. And again, brings up those instances, the NICs, all on their correct subnets. And then once it's done, it automatically configures them. So we don't have to do anything. So this whole thing rolls through. It takes about 5 minutes. So at the end of 5 minutes, we have a Viptela SD-WAN cluster with the base configuration. And now we have to log on to the GUI in order to handle our enterprise certification. So there's a few ways of handling the certificates in Viptela. You can have Cisco handle it, but if you are a large company, you're going to have your own certificate CA. So you're going to want to use your own certificates. And now this is very important when it comes to licensing, because I'm going to dive into licensing in a bit, but the name of your MSP in the Viptela licensing needs to match your DNS, and your vBond has to be of the same DNS 7. So DNS is very important in this, and we want to have everything correct. So we're using DevOpsOnTap.com as the DNS in this situation. And let's just take a look at the configuration of the vSmarts. So after the pipeline, and this is all done through Python, brings everything up and does the base configuration, it prints it out. So we can come in here. It also writes everything to the vault. So let me show you how the vault looks. So if we go again and we look at the vars, this entire environment was built off of just 3 variables. So for every MSP tenant, you can have a different branch in your Git. So this branch is, and that can be named after your tenant. So you can build multiple branches in your pipeline, as many as you want. And in this case, I'm just building one. But the whole idea is here, all you need to build this entire thing is a region availability zone and a name. That's it. The whole thing deploys from that. All right, so let's quickly hop over to the vault, and we can see that because this CI tool, Concourse, can authenticate through to the vault, what it does is when it's building a new environment, it creates a new mount point. So you can see I have all these mount points in here. You can consider these tenants. So this is the multi-tenancy part of the configuration that you would never see or read about or learn in any of the Cisco documentation. So this is the kind of thing that you have to figure out on your own, and this is a common way of doing it. So the vault will automatically create a mount point, and then your pipeline is writing all the artifacts. So I have all the artifacts in here for my customer. So let's pretend my customer's name is US West 1A 2A. So this is my customer / my tenant, or it could be a department in my organization like finance as well. And under here are all the artifacts. So I haven't encrypted these, but in most cases you would encrypt these or base 64 these. You can even put configuration files in here. The idea behind this is that all your code has nothing hard coded in it whatsoever. So if you were to look through this code, there is absolutely nothing hard coded in here, which means it's completely reusable for any other customer or tenant. You can consistently reuse this code, give it a new customer name, tell it to go where you want. I mean, if your customer is in Asia, obviously you're going to want to specify the region in Asia, like Singapore or whatever, in AWS. But essentially, the idea here is that we want clean code. We don't want any configuration in our code. Our code can call configuration files from the vault, but it makes our code very clean and very, very secure. Now, this is something typically you won't see if you go to like most of the DevNet material, right? Things are hard coded. Or if you download the Postman collections, everything is hard coded, and that's not secure. So this is the most secure way of handling your code, right? All right, so I showed you the vault. Let's go ahead and let's see, just quickly, I'm going to give you the AWS view. So let me find it. I have AWS open here somewhere. One moment. Oh, here we go. All right. So I may have to log back in. It may have expired. But if we look at what all this deployed in AWS, right, we can see that we are in US West 2A. And if we go to our VPC, VPC, we can see everything is deployed here, and it's, as well, it's tagged. Now, tagging is very, very important. And you know, if you're just starting out in AWS, you want to make sure you want to tag everything, because you're going to want to delete everything. And what happens if you don't tag everything is, over time they become objects that you can't trace, and it gets very, very expensive. So I can, at any point in time, if I want to blow out everything in this environment, all I have to do is make a vault call and say, vault, bring me back all of these IDs, and then delete them all for this tenant or for this mount point, right? So it enables you to provision to the cloud provider and clean up as well, and have an up-to-date record of all those objects in your vault. So here we, we have the route tables, and we have the internet gateway. We have everything. Now, all right, so let's get into the instances. So like I said, after I brought this all up, there was about an hour of reboots, which you really can't avoid as the cluster is forming. But after all these reboots, what we have is we have a cluster, and then we can start adding our tenants. Now, I've gone ahead and I've pre-provisioned one tenant, but as we can see, right, it brought up everything: 2 vBond, 2 vSmart, 3 vManage. And we can go through and we can look at and see that all the devices are healthy. And this is at the MSP level. Okay, so now there's a few things that are decoupled from the GUI that we set in the code, like site ID, vBond DNS, and the tenancy mode we have to set here. Now, we have to have that base configuration before we can start hitting the API. I'm going to swing into the API in a moment, but before you can actually access and start performing actions through the vManage API, you have to have the base configuration up. And that base configuration, you can do it a variety of ways. Now, some people use Ansible or Terraform, right? I have found for myself, and I'm not saying this is necessarily the best way, but it's the best way for me, is I do everything from Python to the CLI for just the base config, because the base config is very simple. Let me show you. That's my puppy. Okay, so the base config, right? Essentially, you're just okay. He's dreaming. He's fast asleep dreaming. Okay, so there's the system. So the host name and the system IP, site ID, the organization name. This is very critical. This has to match what's in your licensing profile at software.cisco.com. vBond, very important, the DNS. So in the DNS, you have to have, if you're using AWS DNS like myself, let me show you, you have to have both the external IP addresses and the internal IP addresses or it won't work. So I'm going to switch over here to Route 53 and show you how I've set up the DNS here. Now,
and can you increase also the text size a bit, Sherry, please?
Absolutely.
There you go. Yes,
okay.
Thank you.
So the domain name here, DevOpsOnTap.com. If I go down to vBond, bottom, let me just search on it. vBond. There we go. So you can see here that I have not only the external elastic IPs, I have the Ethernet 0, index 0, and the Ethernet 1, index 1. Oh, sorry. Ethernet 0 is index 1, Ethernet 2 is index 2. I think. Okay, I'll confirm that. I don't want to confirm people. These indexes get really confusing when you're working between multiple like Azure and AWS. But you have to have all the IPs in here. Okay, is my all right. So let's swing back then. So before you can hit the API, you have to have this base configuration set. And how I'm doing it here is my job, the pipeline job, is made up of tasks, right? So when the jobs execute, they call these tasks. And in the task, what's happening is it is essentially going to the vault, and it is getting the vManage 1 index 0 public IP, and vManage 1 index 0. Yeah, it's getting that public IP, right? And then what it's doing is it's configuring it with that IP. So it connects with that IP. I'm using NetMiko here. So this is one way of doing it, right? And again, whatever way works for you, but you have to actually get this base config up before you can hit the API. All right, so let's swing back here. We have a cluster app. I've onboarded a vEdge. Let's go ahead and let's take a look at the API now. So at this point in time, we can start working with the API. Now, I have a browser open here with the API. No, not that. Let's just, here we go. All right, so I'm going to switch over to working with the API. I'm actually going to switch over to using a Jupyter Notebook, okay? Now, the management plane in vManage is vManage. It gives us a centralized management plane to connect to. And so when we're connecting to the API, that's what we're connecting to. Now, you can get this connection string off of DevNet. If you just Google Viptela, SD-WAN, Python, authentication, you should be able to find it. So I'm not integrating this with a vault, obviously. But what I want to show you here is we're going to run some API calls. So this is just cookie cutter, right? You just paste this from DevNet, and all you really got to pass in here is your port, your IP of vManage, your DNS, and your authentication credentials. Now, if I was going to be executing this through my pipeline, obviously I would pass these in as variables, right? I'm just doing this because this is for learning purposes. So I'm going to run this again. It's going to authenticate, and it's going to get a surf token. So, oh, I ran the wrong one. No, I did. So here it is. And now what I'm going to do, so I'm authenticated. So the next thing I'm going to do is I'm going to get the device list. So I'm going to run this guy. Okay. You can see it brings it back as a list. So at this point in time, right, I can do whatever I want in Python. I can convert it to dictionary. I can convert it to any form that I want to work with it the best. I can filter it out, and I can start to write my Python modules. Now, there's a lot of things that we can't do with the API. There's still a lot of things that we have to do either via the GUI or via Ansible or via Terraform, or alternatively, there's one other tool that's just not coming to me right now because I'm so focused on the API. But all right, so let's run a couple queries here. So I'm going to bring up in another pane here. I have the actual, is it here? I think I have samples of the API. So, well, anyways, we can just bring it up here. SD-WAN, Vitella SD-WAN API. Okay. And I'm actually not on the latest released, so I'm going to go to my version, which is 20.11. Okay, and I can go to API reference. And we can see here all the things we can do from the API. So this is a little slow, but we can hit the API at data service. So as you can see, when I'm using my Jupyter notebook, right, all the API queries that I'm running are the vManage port data service, and then the string here. So most of what you can do through the API are the general high-level administrative functions, which are very handy if you think about it. If you're an MSP and you have like 100 tenants, you may quite frequently get requests for password resets, for group level administration, especially when you're onboarding a client for the first time. You can handle all of these through the API. Monitoring and alarms. You can do a lot with monitoring and alarms. What you can't do, you can do a ton with backup and restore. Now, what's really nice about this is, say you need to make some configuration changes to your tenant, you can set up your pipelines that you just kick off the pipeline to run a backup, write the configuration files, write the templates, write everything to the vault, and now you're ready to go to make your changes. So it makes backup a whole lot easier, and you can do it per mount point in the vault per tenant, which is really nice. Now, what it doesn't do so well is allow you to actually write your templates and your policies. So what I recommend for that is you actually initially, when you start out, is to use the GUI to write the templates and the policies. And then after you've done it, come in here in the API and do a get and get those policies and those templates that you wrote and look at them in JSON. Now what you can do is you can put those into Git. Make sure you take out any hard coding, right? And now you can use those on a regular basis to make changes via your pipeline. So this is where the automation through the API gets really slick. Okay, so there's some things you can do with cluster management. So I've picked out a selection. I'll let you guys browse on this on your own time. I've selected some standard things, and I've got this all queued up to go in my Jupyter notebook. So we're going to do run the device monitor. So let's run it and let's see what comes back. So we can see that we get a lot of rich data. We get a one-for-one what is in the GUI via the API, and sometimes we're getting a little bit more in the API than what's available in the GUI. So let's go ahead and let's run this one for tenant. Okay. And I can see, if I go back to the GUI, I configured one tenant, and the name is A Spade Cisco. Hold on. Other browser, one moment. Let me find the other browser. I think it's hiding here. Yeah. Yes. So I configured one tenant. So as you can see, I have this Ace of Spades tenant here. And if I go to devices, you'll see that I have one vEdge onboarded and he's healthy. By the way, this vEdge was also automatically deployed and configured in the pipeline. The part that you have to do manually through these is the onboarding. And when you onboard it, I haven't actually found a way to automate this. It probably is possible, but I want to share with you the way I onboarded this. So the way I onboarded it was I actually had to run a command to here. Let's log on here. Arrow up, and I'll show you the command I needed to run. Oops. Am I still sharing?
Yeah.
Okay, I thought I accidentally clicked off on that.
No, it's still sharing.
All right. So if I arrow up here, yes. So when you're onboarding the vEdge, the first step is you have to install, obviously you have to install the root certificate. You have to trust the root certificate chain. And then what you need to do is you actually need to send a request. So this knows automatically to go to vBond, and it will send a request to activate the virtual chassis number and token. And these here, you need to know these before you provision the device, and you set them in the user data file when you're doing this in AWS. You can also do it that way in Azure. So you have to build it with the virtual chassis number and token, and you get that from the GUI. So I haven't found a way to automate that. It's a little bit cumbersome. I am looking for a way to automate it. But let's take a look here. So if I go back to my provider view, okay, and I go to configuration, certificates.
Right, because the vEdge doesn't show yet on vManage, right?
Well, so what happens is you estimate your number of devices in softwareciscolicensing.com, okay, and the types of devices. And then what you get this license file, you install it, and when you do that, all the virtual devices show up, and you get this. I'm in the wrong spot here. Sorry. You get this list of. I'm probably confusing everybody like crazy. I'm sorry. I was in the wrong spot. Let me just find the right place here. Yes, you get this list, and you see I'm in the tenant view. So the tenant gets this list of all their virtual devices, right? Hardware is handled a little bit different. So what I had to do here was on this device, I had to create a bootstrap file, and in the bootstrap file is this chassis number and token, okay? And so what you have to do is you have to put that in your user data file. Let me show you. Configure vEdge. Oh, deploy vEdge. AWS deploy vEdge. Here. And there should be a user data file in here somewhere. So this cloud config file is the bootstrap file. And all you need out of it is this OTP is the token. And I know this is very confusing because they're named differently. And the UID is the virtual chassis number. So what you do is when you bring up this, when you bring this up, you bring it up with that in the init parameters of the user data file. You can see it here. Okay. So vEdge comes up, configure it, install the root certificate, the cert chain, and then you have to run this command, request vEdge cloud activate chassis number And only after that will it show up as being healthy and properly configured. Now, at this point in time, you can start building out your templates. So let's go ahead and let's take a look at templates. All right, so I haven't built out any templates for this tenant. So let's take a look at the provider, because I have built some out at the provider level. All right, so I'm at the MSP provider, and I'm going to configuration templates. So you can see that I have created these templates. Now there's two modes to create template. You can create them in CLI mode. So from featured template or for CLI template. All right. So if we look at these templates, we can see it's essentially like a running config, right?
Mm-hmm.
So when you're initially building out your templates, you may want to go through manually configure a device, be very happy with it, right? Test it out. And then what you would do is you would come in and you would create your template from that running config, and then you can insert variables in here to remove out the hard coding. Then you can apply those configuration templates to many devices, tens, hundreds, and you can create templates that are just for very specific things. Like you may want all the routers in a specific site to have specific DNS or whatever. You can configure them all the same. So you can have many templates for even a single device. Okay. And once you have built out your initial set of templates, then you can start managing them better via the API. So you can request your template via the API, for example, and you can write it to your vault. So you have a copy of that template, all the templates for your tenant, and they are all under that release. So say you want to have a new set of configurations for your routers for that tenant, right? That would be a new branch in your code, and it would include, you would call your templates, you would back up your templates, and now you can go in and you can edit your templates, just the JSON directly in the code, do a git commit push, and have your pipeline push those down. What happens if they call you up in 3 days, there's an issue, and you want to back it out? In your vault, you have the previous release configuration. You can very quickly push it via your pipeline, and they will be back to where they were. So let's go ahead then, and we can see here that we have run a bunch of queries. So how do we now put these into Python, right? Make Python modules out of them, and call them via our pipeline. So, there's a couple methods you can do that. You can actually convert your Postman queries into Python via Postman, and I think everybody knows how to do that. But for example, if you're looking here, this is the SD-WAN always on Postman collection, right? You can find one you like, so device status, and then you just come over here and you hit code, and you can select Python requests, and it will give you the Python requests, and then you can convert these into modules. So once you have these converted into modules and you have figured out your variables, you know that those variables are going to be retained in the vault. And then you can add those into your pipeline. So it's just a matter of creating a new job in your pipeline or editing an existing job, adding in more tasks. So I will pause here for a second. And are there any major questions in the...
There's a bunch of questions in my mind.
Yes.
So for another way would be, right, developer tools as you configure your templates in vManage. You have developer tools open up on the side, and you see all the API calls that get done in the background. So you can capture that with your first template. And then when you create a second one, a third, then you would actually know all the endpoints, all the API endpoints that you need to hit. So that's another way that I would think right off the bat, right, on how to automate your template configuration. Yes, you can do it on the GUI, but if you do it to the GUI, you do it once, just, you can enable developer tools in your browser and just have a look at what's happening, because it shows you all the API endpoints as you create your template. So that would be another way of kind of trying to automate truly everything. Then, so for the CA, right, you were saying, Sherry, the certificate, that's part of your bringing up the underlay pretty much, or like the basic configuration of uploading the cert from DevOps on tap, you said?
Okay, so there's actually multiple ways of handling the cert. So I took the attitude that this MSP has its own root CA, because most of them do, right? So
Yeah.
Acme, whoever, they all have their own root CA, they all have their own security department. So they have rules they have to follow. So they have to use their own certificates, and therefore I took that approach. And there are, let me find the steps. I have the steps documented. Now, it's kind of a chicken before the egg, right? Like, there are API calls to install a root certificate, install a root chain, do all this stuff, but you have to have that base config up first. It's quite complex, so I haven't put all that in Python yet. I actually did the root CA manually, and I have this. I just found it faster for right now, but I do have all the steps here. So they're in. Let me just bring them up. Enterprise cert steps. Yes. All right. So it looks like a lot. It's not. It's a lot of the same thing. Okay. So the first thing, obviously, I did, and you can do this in a test environment via a pipeline using just a little container. Is I created the root CA, and then I installed the root CA into the GUI. So it's just like a copy paste. And then I ran the command to install the cert chain. I did that on all the on one VM, and then on all of the cluster nodes. So you have to put the root CA on a vBond, a vSmart as well, all of them, and even on vEdge. And then you have to install the root chain. So you can actually do this through the API. And actually, then you would have the root ca.pem in your vault, and you would just make the API call to the vault, and it would do everything via the vManage API. Then what you have to do is you have to generate a CSR, and then you create the cert, and then you install the cert. Okay, so once you've done that, you have to you run this on all of the vBond, vSmart, vEdge. All right, and then you have to copy the CSRs over to vManage and create the certs for all the machines that are going to be in the cluster, right? And then, so that's just what all this is. And then on the vEdge only, you handle this a little bit different. You type this command on the vEdge. So after you add the vEdge in through the GUI, you say generate CSR. It pushes the CSR automatically to the vEdge. And then I SSH onto the vEdge. I did request CSR upload, this command. And then essentially what that does is you have to create the cert. So you have to copy that CSR over to vManage, create the cert, install the cert on vEdge. Okay. So this is the manual way of doing an enterprise root CA. You can do all these steps through the API. I just haven't done them myself yet. It's going to take me a little bit of time. It's probably going to be like a day of work, actually. I would say if I was an MSP and I had like 100,000 tenants, this would be on my like number one list to do. Okay. And then essentially essentially, these are the rest of the steps here. So just essentially, you want to make sure that the NMS service is still running. You may want to restart it, and then I'm just doing some show control connections history and so forth. And then it's just the VIA job onboarding, and I already showed that step, how you have to get the token and you have to get the boot config file, put it in the user data, put the virtual chassis in the token user data file, bring up the VEdge with that. With hardware, it's a different process, obviously, because it already comes with it. It's not a virtual chassis number, it's a real chassis number. And so, but you still need the token. So at this point in time, right, let me flip over. Do I have a few minutes? Any more questions?
Yeah. We have 10 more minutes.
Okay, I wanted to show you guys the licensing because, to be perfectly honest, I feel like this part is the easy part. For me, the confusing part and the part that I always struggle with is the licensing. And so let me log into softwareciscolicensing.com. And now, what's really interesting about this is softwareciscolicensing.com has an API. So theoretically, we could do this all through the API. I haven't gotten to that part yet. Now, this API, I don't believe, well, so this is a Swagger API. I'm not sure about ciscosoftware.com. But long story short, if you're going to do it through the GUI, and I have to 2FA here, so just bear with me quickly while I put the code in to my phone, which I should have a push set up, but I don't. Oh, okay, it's going to let me. So for setting up an MSP, it's a little bit of work. So you can see here I am the MSP. This is my top level organization. And under here, I set up all my tenants. So let's go back and software home. So the first thing you have to do is have a smart account. And then you have to set up virtual accounts. So you can see my smart account is to my root domain here. So for every tenant, you have to set up a virtual account. So I had all these set up as a casino theme for Cisco Live. That's why they're all named after card suits. So Ace of Spades is the one that we're using as the example today. This one. Okay. And after you have the virtual account set up, you have to do that licensing guesstimator thing. You can add in access. So this is where you would add in, you may want to add in your tenant's admin. So the MSP who's doing, if you're selling a managed service, and then you may want to add in, I'm not sure, you may want to add in your tenant here. You can add in groups. And then essentially, after you've done all that with the virtual licenses, you have to, and the access, you have to come back here. Oops, I went to the wrong spot. And you go into the software manager, manage licenses. Okay. And you go down to this guy, inventory. Okay. And you switch to the virtual account. So this is your tenant, so Ace Spades. And you can see here that this is where you can generate tokens. And this is where you can get your licenses. Now, I'm not sure why this is grayed out for me. So previously, I had under actions, create new license file. And then I had to estimate my virtual devices. And after that, I was able to download a serial file, a Viptela license file. I'm not sure why this is grayed out. I'll have to find out. It could be that it expired for me. But then that license file, what you have to do is you have to come in to vManage. Once vManage is up and running, and you have to actually install that license file here. And then what happens is you do the same for your tenants. And that's how I have, these are all virtual licenses that are allocated to my tenant. All right. So the licensing is complicated. It has changed recently, but you have to make sure that all your DNS matches. So when you set up your tenant, like you have to make sure you saw how I set up the vBond in Route 53, right? Your
Mm-hmm.
your tenant has to be set up appropriately as well. So um, we do have a detailed video on setting up the licensing on YouTube. So if you just and it steps through it, and it's really really great. It goes through all the steps. So I'll stop for questions. A lot of information.
All right. So can we find this pipeline in a GitHub repo publicly somewhere?
So right now, this is private, and I am gonna be moving it to DevNet very soon. It just has to go through security scans and different things to make sure, because this is coming from a lab, that make sure it has nothing like any keys or anything in it. So once all that happens and it's all security scanned, it will be available publicly on DevNet, and you can run the whole thing in Kubernetes, and it's very low cost. So I keep, and you can delete it when you're done, and then you can spin it up again anytime. Um, but the thing to know, right, is that let me just show you here quickly. So the pipeline, where's my pipeline file? Yeah. So the pipeline, right, is just a YAML file which
Mm-hmm.
calls all the jobs, and each job has tasks, and in parallel of jobs it can run at the same time. So like it can throw out all the instances at the same time, and then it can configure them all at the same time, right? There's no dependencies there. So tasks that can happen all at the same time do, and it makes it very fast. So it's like parallel processing for your DevOps. Um, And then this is just Concourse is just a Helm chart installed on a small 3 Kubernetes cluster in AWS. I didn't get to the Azure stuff. I guess that would be a separate hour. It is very different. And by the way, this is much more highly performant in Azure, but it's a completely different process, right? Like the VHD creation, these AMIs that are used to build these instances are built from the VHD download on softwareciscolicensing.com. I forgot to mention that. When you are building AMIs from the VHD in AWS, totally different process than in Azure. In Azure, it's much more complex. So um, I actually forgot to go over that. Yeah, but you have to actually get those VHDs downloaded, and then you have to build AMIs. That's actually one of the first things you can do. And one of the VHDs is 20 gigabytes for vManage. So before you go to bed at night, right? So the best way to do it is to bring up a little Ubuntu or a Windows instance in AWS. From that instance, log on to ciscosoftwarelicensing.com. Download it to there because it's 20 gigabytes, and then it goes really fast. If you download it to your desktop and then you try to upload it to S3 and then you try to like do it that way, it's going to take like 12 to 24 hours, even if you're on a fiber connect. So I would recommend just doing it the first way. It's faster.
All right, so you actually have to build your own AMI images from the VHD files, right? They're not available in the marketplace in AWS, or you pretty much have to do it yourself,
Right.
building.
You also have to specify when you're building Yami, you have to specify create the disk and everything, format the disk, and you have to um, specify the operating system type. If you don't do that, it comes up, but you can never log on to it. It won't work because the operating system hasn't properly installed, because AWS isn't able to by default detect the operating system type on these. So you have to manually specify it. And there are a set of steps in here somewhere for that. Let me see if I can find them real quick. They're somewhere in the repo, those instructions. And then I
So,
have them for Azure too.
all right, so we have the instructions. Then let's keep an eye out on when the repo will be publicly available. I'll be really curious to start sharing because this is really great work, right? It's been really nice to see pretty much a whole fabric that gets deployed fairly automatically in AWS, right? So if you're an MSP, using this pipeline is a no-brainer really for me because it just automates so much of the manual process that you have to go through as you set up your customers. So I think this would be invaluable for MSPs.
Absolutely. And because everything's variabilized in the Python, you don't have to use Concourse. I mean, you could adapt it to
Yeah.
CSI, Jenkins, whatever you're currently using. But this is specifically to use with Vault as an artifactory. And actually, it was a good choice because if you read Gartner, HashiCorp Vault just made it like it's the top solution in the Gartner report. So I'm going to stick with recommending the Vault. However, you could use Azure Vault or AWS Vault. Those both work as well.
Perfect. Well, we're top of the hour, and Sherry, we'd love to have you back if you want to cover also the Azure piece, right? Would definitely love to have you back in a couple of weeks. Give folks a chance to review this, rewatch it, and get their questions in. This is really great. Thank you so much. Thanks everyone for joining us. Sherry, like I said, let's do this again with Azure in a couple of weeks. I'll put it on our calendars, and everyone will see you next week, same time. We're going to cover Meraki next week, so be on the lookout for that. Sherry, thanks again. Thanks, everyone, and we'll see you on the next one.
Thank
Bye,
you.
everyone.
It was fun. Have a good day. Bye. Bye.
Bye.